Hello class, this is part 2 of our Calc AB notes for trig integrals. We're on section 8.3. So I wanted to add something really quick. This also works, this Wallace's formulas also works for sine to the nth power, sine x to the nth power. So just wanted to add that on. I feel like there's only a couple homework problems that use that, but it is really cool when you can use it. So we're looking at secant and tangent today, and this is always trickier for people. So we just want to review a bunch of stuff first. Pythagorean identity, 1 plus tangent squared theta equals secant squared theta. So that's the first thing, Pythagorean identity, and then we just want to kind of go over derivatives and integrals. So if I have y equals secant x, my y prime, my derivative, is going to be secant x tangent x. So that means if I'm integrating secant x tangent x dx, I am going to get back secant x. And if our y equals tangent x, well then our y prime is going to equal secant squared x. And so if I'm integrating secant squared x dx, that means it is going to equal tangent x. So there's a bunch of different guidelines I can write out, and I don't know how helpful they are. For me, I just kind of like to go through and think about the problem and like kind of play with it a little bit, but sometimes the guidelines are nice for people that don't know where to start. But they're pretty complicated. So if secant is positive and even, we are going to keep the secant squared x, and that's because it's going to be part of our du. If tangent is positive and odd, there we go, we are going to keep secant x tangent x, and that's again as our du. If only tangent, and this is when it's odd and, or no, even and positive. See, it's a lot to keep track of. We are going to use Pythagorean. So basically just changing it all to secant. Let's see, what else? If only secant, only secant, and by only secant we mean odd and positive. We're going to integrate by parts. And then if all is lost, so if you're ready to give up, just try changing everything to sine and cosine. Okay, so our first example, we have, let's see, we've got the integral of tangent x cubed divided by the square root of secant x dx. So if I look at my rules say if tangent is positive and odd, keep secant x tangent x. And I guess for me, the other thing, so that means my du that I want to save is going to be the secant x tangent x. And for me, the other thing, just looking at this, is that my secant is in my square root. So we're kind of like where we were at with part 1 of the notes, where I can't really do anything with that square root. And so my u is really going to have to be, sorry about that, my u is going to have to be the secant x. And if my u is secant x, my du is secant x tangent x dx. So I have to have a secant x tangent x in there. Let's play around with this a little bit. So I think the first thing that we want to do is this tangent cubed x. I need to have like just one factor of tangent x for my du. So I'm going to write tangent squared x. And then that secant is in the denominator. And so that's going to become secant x to the negative 1/2 power. And then I still have a tangent x here. So all I did was like move up that denominator and then broke apart my tangent x. So I know I've got to save a tangent x, but I also need to have a secant x. So this is where it's going to get a little bit weird. I'm going to change my, let's see, what am I going to do? I'm going to change my tangent to secant squared x minus 1. And then my secant x, I need to like take a factor of secant x out of there. So that means now I'm going to have secant x to the negative 3/2 power times secant x tangent x dx. So now I've got that du. So think about how this secant is to the first power, and negative 3/2 plus 1 makes negative 1/2. So I know it's really weird, but I'm totally allowed to do that. All right, so now I want to take and distribute here. So I'm going to distribute secant x to the negative 3/2 power here and here. So I'm going to do that. And remember, we're saving this part as our du, so we're not going to touch that secant x. So let's see, over here, when I distribute this, negative 3/2 plus 2 would be a positive 1/2 power. So this is going to give me secant x to the 1/2 power minus secant x to the negative 3/2 power. And then brackets around all of this. And then we still have times a secant x tangent x dx. And so really, if my u is secant x, this is like having a u to the 1/2 power minus a u to the negative 3/2 power. And then this is my du over here. So I'm really just doing power rule now. So I'm not even integrating secant or anything, right? Like I'm just integrating this u to the 1/2. So that means if I have a 1/2 power and I add 1, now I'm going to have 3/2 power. So I'm going to have secant x to the 3/2 power, and then divide by my new exponent, which means multiply by the reciprocal, so 2/3. I've got a minus here. And then if I have a negative 3/2 power, when I add 1, I now have only a negative 1/2 power. So secant x to the negative 1/2 power. And if I'm dividing by negative 1/2, then I'm multiplying by negative 2/1. So this is a minus, minus, makes a plus, and then plus c. And I think I would just leave it like this. Like it's just kind of a mess. But you can see that these are just kind of tricky. I think they're a lot trickier than sine and cosine. So on the next one, I have secant is 4th power. So what I could do is I could get everything in terms of tangent. Really, we can go either way on this one. But when I have the option, I like to make my my du the squared, right? So if my du is going to be secant squared 3x. Ooh, that's going to be a mess because it's a 3x. I have to have a 3 here, and then my dx. If that's my du, then my u is just going to be tangent of 3x. Okay? So I have 4th power for secant. So let's make it a secant squared 3x, another secant squared 3x, and a tangent cubed 3x dx. And like one of these guys I'm going to save for my du, and then one of them I'm going to change. This one I'm going to change. I'm going to use Pythagorean and change to tangent. This one could go either way because there's the odd on tangent. So you could either use our first rule or our second rule. But I just really, this was easier for me, I think. I think this one always turned out better. So let's see, secant is going to be 1 plus tangent squared of 3x. And then I have times a tangent cubed 3x. And then I have times a secant squared 3x dx. Okay. And then, so I've got my du kind of set there, but this tangent, I do need to go ahead and distribute this here. So let's see what we get. This is going to give us the integral of tangent cubed 3x plus, brackets are necessary, or parentheses or something, tangent, this is going to be 5th power. And then remember, we did need that 3 in there. So I need to have 3, that doesn't look good. I need to have 3 secant squared 3x dx. So now all of this is going to be my du, but I multiplied by a 3. So I've got to have a 1/3. And this is going to be like u to the 3rd power, and this one's u to the 5th power. So now it's just power rule again. So my new power for the first one, if it's 3rd, it's going to be 4th. So tangent 4th. So tangent of 3x raised to the 4th power, basically, right? And then I would want to divide by 4, but I already had a 1/3 there. So 1/3 times 1/4 is 1/12. I'm kind of doing this. In class, I might break it down into 2 different steps, but I don't have a lot of space here. And then this one's 5th power, so when I integrate now, I'm going to get 6th power. And there's a 1/3 already there, but then I have to divide it by 6 as well. 1/3 times 1/6 is 1/18. And then I've got a plus c. Two more problems here. The next one is a definite integral. Tangent is just all even, right? All even, tangent only. So this is when I want to use Pythagorean. And that's because if I have a squared, a secant squared, I can integrate that, but I can't integrate like a tangent squared or anything. So let's go ahead, 0 to pi over 4. Let's make it secant squared x times, or sorry, tangent squared x times tangent squared x. Getting ahead of myself. Okay. And then I don't know if I want to convert them both or not. So I'm going to just convert one for now into secant. So it's going to be secant squared x minus 1. All right, and then when we distribute, we're going to get secant squared x tangent squared x dx minus just tangent squared x dx. So this first one's really okay, right? Because if our u is tangent x, then our du is secant squared x dx. So this is going to be like a u squared for the tangent and then the du. So like the first part of it's good, but the second one, I can't do anything with tangent squared. So I'm going to have to do something with that again. So let's just kind of rewrite. I'm going to rewrite so that my tangent squared x is first, and I have my secant squared x dx here. And then the second one, I definitely want to change that into secant squared x minus 1. And really, I could just integrate right now, or I could do one more step and kind of pretty it up a little bit, make it easier for you to see. So that means 0 to, forgot to go back to my pen. Let's see, 0 to pi over 4, tangent of x, because that's my u squared, times secant x dx minus, from 0 to pi over 4, secant squared x dx minus, from 0 to pi over 4, just dx. Oh, this would be a plus, because I have a minus and another minus. Okay, so on the first one, I have a u squared and I have a du. So when I integrate, I'm just going to have tangent to the third power now. So I'm going to have 1/3 tangent x. This is going to all be to the third power minus my second integral. I'm going to do my bounds at the end for everything, like the whole thing. And then the second one, when I integrate secant squared, that's just tangent x. So this is just going to be a tangent x. And then the last one is just going to be a plus x. And this is all from 0 to pi over 4. So I am going to have to find the tangent at 0 and the tangent at pi over 4. So at pi over 4, that's when my x and y sides are the same. So like 1 square root of 2. So my tangent's just 1. At 0, let's see, my xy, let's see, that's 1, 0 at a 0 degree angle or 0 radian angle. And so my y over r is 0. So my tangent at 0 is 0. So let's go ahead and plug these in. So I'm going to have 1/3. Let's see, tangent of pi over 4, we said was 1. So 1 to the third. Tangent of pi over 4 is just a 1, so I don't need to write tangent. I can just write 1 minus 1 plus pi over 4 minus, then we're going to plug in the 0. 1/3, tangent of 0 is just 0. So that's going to be a 0. Tangent of 0, 0 again, plus 0, like that whole thing just is a 0. So let's see, we have 1/3 minus 1 plus pi over 4. So basically just like pi over 4 minus 2/3. All right, last problem. That was a little bit tricky at the end, but it's good for us to do the trig by hand. We really need that extra practice. So for our last one, we have a fraction secant x over tangent squared x. So let's see, what if maybe just rewrite this like 1 over tangent squared x times secant x dx. That the problem is that fraction, right? Like this is, if our u was our tangent x, then we could have like a u to the negative 2 power, but then our du would be secant squared x, and we don't have that. So this just really isn't working, is it? So we could try integration by parts, but we could also just try converting everything to sine and cosine. And since the exponents are pretty low, like I have a good feeling about that. And I've already done this before. So let's think about, maybe I'll go back and rewrite the way I had it. 1 over tangent squared x times secant x dx. So remember, tangent is sine over cosine, but this is reciprocal of tangent because it's 1 over tangent squared. So instead of sine over cosine, I'm going to have cosine over sine. So cosine squared x over sine squared x. And then my secant is reciprocal of cosine. So that's going to be 1 over cosine x. So this is kind of nice because we're going to, I think so anyway, because we're going to factor out a cosine, right? If I have cosine squared over cosine, now I just have a single factor of cosine x in the numerator. So then if my u is sine x, because that's the more complicated one, that's the one that has the power, right? Then my du would be cosine x dx. So now we're getting somewhere. So let's make this sine x to the negative 2 power times cosine x dx. So now basically what we've got is we've got like a u to the negative 2 power. Here's our du. So I would need to add 1 to my exponent. So this is going to be sine x to the negative 1 power, divide it by a negative 1. And I'm not sure the best way to write this. Like I could write it as negative 1 over sine x plus c, or I could even use reciprocal trig and write negative cosecant x plus c. So different options on how to write out that answer. So this was just a lot more playing around with trig integrals today. I think it's good for us to be working with trig. I think we need the practice. That's why I really like this section. I know it's a little bit painful, Please don't just use Calc Chat and copy down what they have and make sure you're understanding it. That's not the same as trying to do something on your own. So some of you have really become over reliant, I think, on Calc Chat this semester. These are tricky. You might guess a U and a DU and it doesn't work, and you have to do something else. But we tried to have kind of a wide variety of problem solving in notes. You've got some examples to look back on. So as always, if you need help, please make sure that you ask and that you're getting help.